To install the software, put the software disk into the computer and open the file. Double-click on Setup. Click Next. Here you can input your username and company name, and then press Next. Choose where you want to install the software and click on Next. Tick Run Program and then press Finish. After install the software, switch on A500. If you connect with USB connection, the software will give you a prompt, remind you to install the USB driver. The USB driver folder is located under Program Files, AAV Software, and here you can find the driver folders. Just follow instruction to install the USB drive. After install the USB drive, switch off A500 and then restart the computer. Afterwards, switch on A500. After restarted the computer, go to Device Manager and find USB serial port. Remember the COM number. And then go to AAV Configuration Program. Choose the communication port number. In case you are using a Flame A500, just click on the Flame and then OK. To use the AAV software to control A500, please make sure to switch on the computer first and then power on A500. Please confirm that the number 1 position in the lamp turret has a lamp inside, and then double-click on AAV software. Press OK. Normally we choose online mode to run the system. In case you want to take the record or the data of the testing, you can choose offline mode. Now we choose online mode and press OK. The system will integrate automatically. The initialization takes a few minutes. Now the initialization finished. It will show you how to set up the lamp. There are 8 positions in the lamp turret, so you can choose the element of its position by double-click on the position number. For example, we're gonna double-click on number 4 because now in the lamp turret is a mercury lamp, so we click on mercury and press OK. Now the number 4 position has been changed to mercury lamp. For working lamp and warm-up lamp, you can choose as your application purpose. For example, we take a number 1 copper lamp as a working lamp, then we choose number 1 position. We choose mercury as a warming up lamp. And you can exchange the working lamp and warming up lamp position by clicking on Exchange. And now we press Next. This interface is to set parameters of the working lamp. For work lamp current and warm-up lamp current, we normally take the default value. Slit, most of the time we choose 0.4, but for different element, you can take a reference from our cookbook. Negative high voltage, again, you can keep the default value. Now we press next. This interface will set up the wavelengths. Normally we take the default value and search peak. It takes a few minutes to the system to search the peak. As we can see, the standard peak should be 325.75. The actual measured value is 324.35. The deviation is 0.4. In this case, we need to do wavelength validation. And click on next. Finish. To do wavelength correction, make sure the mercury lamp is in the lamp torrent. Then here we press Application and choose Wavelength Correction. The system will automatically recognize the mercury lamp. We just press Start. This process takes 15 minutes to finish. When the wavelength correction is finished, it will show complete. Then we go back to lamp to search peak again. This time, the peak is at 324.75 nanometers. It's exactly the standard value. Hence, it is within 0.25 deviation. It's acceptable. Now the instrument is ready to use. Next is to set up sample. I simply press this button. In this interface, we have correction method, curve equation, concentration unit, standard name, and start ID. For flame analysis, we always use calibration curve. If we have samples with a high concentration, we normally use second or third equation. But most of the time, we choose the concentration, the first equation of concentration about absorbance. For the concentration unit, you can choose at your choice. And here input the standard names and start ID. All finished, we press next. This table shows the information about standard sample. We can add or reduce the number of standard samples by pressing increase or decrease. For the concentration, we can double click and then input the concentration value manually. For example, we have 4 standard samples with concentration of 0 for number 1, 0.5 for number 2, 1 for number 3, and 2 for number 4. Then we press next. To ensure the system works stably, you can choose to do blank correction or sensitivity correction. If you want to choose blank correction, you can just tick here and input the number of samples, and this will be same for the sensitivity correction choice. In this case, that means after every 5 samples, the system will do the blank correction and sensitivity correction with the non-standard sample concentration, and then press next. This interface is to set up the information of annual samples with the total numbers, sample name, start ID, weighting factor, dilution factor, volume factor, and correction factor. These 4 factors will help the software to automatically calculate the actual concentration of the samples. That will shown on the main interface of the software here. Then we press finish. We finish all the sample setup. Then we set up the parameters of the measurement. In the regular interface, here we can input the number of repeats for the standard annual samples. If you choose the blunt correction and the sensitivity correction under the sample setup, here you need to put in the repeat times. For flame setting, we have two choices for measurement mode, automatic or manual. If you choose manual, for every measurement you have to manually press start. If you choose automatic, the system will do the measurement automatically. And here we put in interval time and sampling delay time. We suggest to put the 1 as the interval time and the sampling delay. On display interface, here we set up the ABS and the time of this table. The maximum and minimum value of ABS represents the figure of absorption on this y-axis, and the time unit here is minute. That represents the figure of the x-axis. For the signal processing, there are three choices for calculation mode. Heat is used for graphite furnace. Area is used for hydrate generator. The serial is for flame analysis. For integration time and the filter factor, you can get reference from our cookbook. On QC interface, here you can choose to control the quality of either concentration, absorbance, standard deviation, and the relative standard deviation. For instance, if we want to control the concentration, we can click on concentration and set up the highest value and the lowest value here. And also choose the action in case the value is over the range. You can choose either continue, stop, or remeasure if the value is over the range, and by making a mark here. Effective range, this is to put the minimum and maximum absorbance. After setting all these parameters, simply press OK. After setting up the samples and the measurement parameters, you click on the instrument, check the burner head, and then here will show the type of burner head on the instrument. Now we press flame. This column here shows the gas pressures, liquid trap, and the emergency switch status. Press the status checking button. If the gas pressure is on the regulated pressure, it will show on. If not, here will show off. The liquid trap must fill up with water, then it shows on. In case the water is not enough, here will show off. For the emergency button, when the instrument is in ordinary status, it is on. In case the flame is off in an emergency situation, the button was activated. This shows off. Now the software shows support air pressure valve is off because we haven't turned on the air compressor. Now we turn it on and press the status checking again. Now we can see the status of support air changed to on. Next step is to adjust the burner position. We need to take the path aiming block and place it on top of the burner. Observe the beam if it is right on top of the slot. If not, we need to rotate this knot to make it forward or backward of the burner. Next is to place the block inside the slot and observe this beam from left side to right side to ensure the whole beam passes through the block. If not, adjust it with the right handle. Just now we showed how to adjust the burner position manually. For a flame-only atomic absorption, you need to manually adjust the position of burner head as we just showed. For a combined flame and a graphite furnace system, the position of burner head can be automatically adjusted by the software by simply input the figures of the position. For the height of the burner, we suggested to put the value of 5 or 6 and then press the enter on the keyboard. Then the system will automatically set up the height. For the ideal height, you can adjust it according to the absorbance readings. Now the system is fully ready for ignition. Simply press fire. For the first time of installation, please ignite the fire a few times to ensure the gases reach the system. Now we need to input the figures of gas flow. Start with 1000 and then press enter to see the changes of the flame. Now we input the flow rate of 2000. Press enter to observe the fire again. Now we enter 2500. Press enter to observe the fire. Different gas flow rate, you can see the differences of the flame. So for different element analysis, please refer to the cookbook to set up the proper flow rate. In case of any emergency, press the emergency button. The button is on and the flame is off. Then we check the status again. Here it shows emergency switch is off. Also, we can use this button to switch off flame. To do a calibration curve, take copper as example. Press flame and enter the flow rate as 1800 and press fire. Then the flame is on. Press energy, auto balance, and close the window. Put the capillary in the blank and then press 0. Press measure. Start. Now we put the capillary into the standard samples. When the signal is stable, press start. And we repeat the process for the rest of the standards. Once finished, this calibration curve window will pop up. Please check the linearity here. If it meets your requirement, press OK. And finally, put the capillary into the blank. Wash it before put it into unknown samples. Now we do sensitivity. Prepare 2 ppm copper standard solution and copper hollow cathode lamp. First is to set up a parameter. Input 7 as repeat times, then press OK. Then press measure and put capillary into the blank. Press 0. And then put the capillary into 2 ppm copper solution. When the signal is stable, press start. The RSD value represents the sensitivity here. This figure should be less than 1%. Now we put the capillary into the blank. To clean the capillary, when the signal is stable, we press 0. Then press start to take the absorbance readings of the blank for 7 times. Now write down the figure of standard deviation prepared for the calculation of detection limit. To calculate the detection limit, please follow the below formula. S represents the standard deviation of the blank, which is 0.0002. C represents the concentration of the standard solution, which is 2 ppm. A represents the average absorbance value, here which is 0.323. The detection limit should be less than 0.008 ppm. To switch off the flame temporarily, you can simply press the switch off button on the software. To safely switch off the flame, first you need to switch off the gas valve, and then flame is off. The gas is completely burned in the pipe. Next is to switch off the air compressor. Press off the power button and press down the release valve until the meter turns to 0 position. To save the data, firstly to choose the path where you want to save the file, and then name the file and press save. Print the data, press this button and choose which one you want to print out. Alternatively, you can press Control and make a multiple choice. Simply press print. The combined print that will print out all the contents. To change the lamps, press power off button first, and then change the lamp, put it back, then press OK. Background correction is under the instrument job box choice. You choose background mode. Choose deuterium lamp and then press execute. And press OK. Go to energy. Press advanced. And choose deuterium lamp motor. Now we place the aim beaming block on the burner. We can see there are 2 beams. The red one is from the hollow cathode lamp. The purple one is from the deuterium lamp. We need the forward and backward button on the software to make the two beams into one. Just like this. The green line here represents the energy of hollow cathode lamp. The red line represents the energy of deuterium lamp. We can increase the deuterium lamp current and decreasing the hollow cathode lamp current to ensure that these two energies are the same. Please pay attention, the maximum current of deuterium lamp should be less than 80. And then increase the negative high voltage to make the energy of both lamps to 100. Just like this. Back to the main interface of the software, this figure shows the total absorbance. This represents the absorbance of background. There's another choice for background correction, which is self-reversal. So click on self-reversal, press execute, and then press OK. Again, go to energy. By increase the narrow pulse current or reduce the broad pulse current to make sure these two energies are equal. And then by increasing the negative high voltage to increase both energy to 100. Just like what we did now. And then press close. Again, here shows the total absorbance. And this figure is the background correction.